Hello and welcome to Module 5 of Power BI. In this module, we shall be looking at data modeling and relationship management. By way of introduction, why data modeling matters. The objective here is to learn how to structure data, establish relationships that enables accurate, efficient analysis in Power BI. The reality is that after data is cleaned and transformed, it must be structured for analysis. Therefore, data modeling determines how tables are organized and connected. Without proper relationship, report becomes confusing, inefficient, or inaccurate. What this model covers include understanding data models and relationship, creating and managing table relationship, star schema and snowflakes schema design, calculated column measure and hierarchies. Finally, we will also look at data modeling best practice. By the end of this module, you will structure data effectively and prepare it for advanced analysis and visualization in Power BI. Let us begin with what data model is all about. A data model is the logical structure that organizes data into tables and defines relationship between them for analysis. The main component of data model include tables, columns, relationship, and the keys, which is primary and foreign keys. Now, fact table store numerical transactional data which is used for calculation and analysis. Example of fact table include sales amount, profit, quantity, and revenue. We have dimension table which store descriptive information used for filtering and categorization. Example, customer name, product details, date, and region. Why fact and dimension table works together? Fact table answer how much and how many, whereas dimension table answer who, what, where, and when. Together, both of them provide complete business context. The key insight here is that a fact table without dimension is just number with no meaning. Therefore, dimension without fact are just lists with no measurement. Having known that, let us now look at understanding relationship in Power BI. What is a relationship? It is a connection between two tables using a common field, that is the key, that allows Power BI to combine and analyze related data. Example, sales table contains customer ID, customer table contains customer ID and customer name. The relationship on customer ID allows analysis of sales by customer name. Now we have different types of relationship. We have one-to-many relationship, which is one ratio as. Here, it is the most common relationship in your Power BI. One record in a dimension table relate to many records in a fact table. Example, one customer can have many sales transactions. Another type of relationship is one-to-one relationship, which is very rare and it is used in specific cases. Here, one record in a table relates to exactly one record in another table. Example, employee table linked to employee details table. Now, another type of relationship is many-to-many relationship. Here, it involves complex relationship requiring careful design. Here, many record in one table relate to many record in another table. It should be avoided when possible or handled with bridge tables. Now, key in data model include we have primary key, which is uniquely identify each record in a table, like customer ID in customer table. We have foreign key that links to a primary key in another table. Example, customer ID in sales table. The key insight here is that the one-to-many relationship is the foundation of most Power BI data models. Having known that, let us now look at creating and managing tables relationship. Why do we create relationship? Tables do not automatically understand how they are related. Relationship must be created to enable cross-table analysis. Two ways to create relationship. We have automatic creation. Here, Power BI automatically detects relationship when data is loaded based on matching columns, names, and data type. It works well for simple models, but may not capture all intended relationships. We have manual creation relationship, which is recommended for control. Under the manual, if you want to create relationship, go to model view in your Power BI, then drag the field from one table to another, or use manage relationship new, then select the related table and column, then define the relationship setting, either cardinality or cross-filter direction, then click OK to create the relationship. Then managing existing relationship, the key management option here, the option include edit the relationship, you can delete the relationship, you can activate or deactivate the relationship, you can change the cardinality or adjust the cross-filter direction. So this is the key option for managing existing relationship. Now, cross-filter direction, we have single direction here, filter flow from one table to another. Then we have both direction, which filter flow in both direction. The best practice is use a single direction filtering unless you have a specific need for bidirectional practice. Now let us look at Tashima, which is the preferred Power BI design. What is Tashima? It is a simple data model where a central fact table is connected directly to multiple dimension table, resembling a star shape. The structure of Tashima includes it is one central fact table. It contains multiple surrounding dimension table and has direct relationship between fact and each dimension. Example of Tashima include fact table, which contains sales amount, quantity, customer ID, product, and date ID. Now we have dimension table that which is customer that contain customer ID, city, name, product, which contain product ID, name and category, and then date, which contain date ID, year, month, and quarter. Advantages of Tashima is that it is easy and simple to understand. It is faster query performance. It is preferred and recommended in your Power BI. Then it is easier to build report and dashboard. Finally, it works seamlessly with Power BI Visual. Why do we need Power BI love? Why do Power BI love Tashima? Power BI's Vertibag engine is the optimized tool for Tashima. Queries run faster because relationships are straightforward. Task calculations are easy to write and debug. The key insight here is that Tashima should be your default choice for most Power BI projects. Now let us look at Snowflake Schema and Schema comparison. What is Snowflake Schema? It is a more complex structure where dimension tables are further normalized into sub-dimension tables, resembling a snowflake shape. The structure is that it is a fact table at the center. Dimension tables split into multiple related tables, and more relationship and joins between tables exist. Example of snowflake schema is product dimension normalized into product, category, and subcategories. Then location dimension normalized into location, city, state, and the country. Advantages of Snowflake schema is that it reduces data redundancy, it is more structured and organized data, it saves storage space in your SOX database, and it is useful for large enterprise systems. But the disadvantages of Snowflake schema in Power BI is that it is more complete. It contains more complex relationship, which is very difficult to understand. It is lower query performances, and it is very harder for business users to understand, and it is not recommended for your Power BI reporting. Now let us look at the comparison of Star Schema and Snowflake Schema and which one to use in your Power BI. When you are considering in terms of structure, Star Schema is very simple, but Snowflake is very complex. In terms of number of joints, Star Schema has few number of joints, Snowflake has many joints. Then in terms of performances, Star Schema is very fast, but Snowflake is very slow. Then in terms of understanding, Star Schema is very easy to understand, but Snowflake Schema is very difficult to understand. Which one is recommended in your Power BI? Star Schema is recommended, but Snowflake Schema is not recommended. The key insight here, prefer Star Schema for Power BI project. If your stocks data is in snowflakes, consider denormalizing it during report. Now let us look at calculated columns, which is row level calculation. What is calculated column? A calculated column is a new column created in a table using DAX formulas. Values are computed row by row and stored in the data model. The key features is that it is calculated during data refresh, not in real time, and it is stored in data model. It works at a low level. Each row calculated independently, and it is calculated once and then stored. Example of calculated column: total sales will now be equal to quantity times your unit price. This creates a new column in the sales table where each row shows the product of the quantity and unit price for that transaction. Then now let us look at use cases for calculated column. Creating new attributes or categories, data categorization, row level calculation that are needed as static value, concatenating text value. Example, first name and your last name. When to use calculated column? Calculated columns are used when you need the calculation at row level for filtering or grouping. It can also be used when the calculation does not depend on the report filter. It can as well be used when the calculated value will be used across many visuals. Limitation of calculated columns is that calculated columns increase model size because they are stored. Therefore, use them only when necessary. Now let us look at measure, which is the dynamic aggregation. What is a measure? A measure is a dynamic calculation used in report and visual. Unlike calculated column, measures are calculated on the fly based on users' interaction, filters, and slicers. The key feature of measures is that measures are calculated at query time. Measures are not stored in the data model. Measures respond dynamically to filters and slicers. Measure is more efficient than calculated column. Examples of measure: here total sales will now be equal to sum sales bracket amount. Then average will now be equals to product divided by the price. Then sales count will now be count bracket sales transaction ID. Now, over the year's growth will now be equals to current year minus previous year divided by the previous year's sales. Now, uses case for measures. A measure can be used for aggregation, which includes sum, count, average, minimum, and maximum. It can be used for KPIs, that is key performance indicators and performance metrics. It can be used in dynamic reporting where values changes based on user selection. It can be used in ratio and percentage calculation. When do we need to use measure? We use measure when we are dealing for any calculation that will be used in a visual or dashboard, when the calculation should be respond to report filters, and it can be used for aggregation that summarize multiple rows. The key insight here is that measures are generally more efficient than calculated column because they are not stored and only compute when needed. Having known that, let us look at calculated column versus measure, the key difference. Calculated columns are row level calculation. They are stored in data model. They are calculated during data refresh. They do not respond to report filter. Example, full name will now be equals to first name and the last name. When do we use a calculated column? You use it when there is need for row level categorization or static value. Now for measure are aggregate calculation. They are not stored. They are calculated dynamically. They respond to all report filters and slicers. Example, total sales will now be equals to sum bracket sales and amount. When do we use measure? We use measure when you need dynamic aggregation, KPIs, and performance metrics. Which one should you use? Prefer measures for sum, average, count, and other aggregation. Prefer measure for KPIs and performance indicators. Any calculation that should respond to users filter. Then when do we use calculated columns? We only use calculated columns only when you need row level categorization, when the calculation does not depend on filter, and when result will be used to filter or group data. Performance consideration: calculated column increase model size and refresh time. Measure have minimum impact on model size but can impact query performance if overly complex. The key insight here is that when you are in doubt, try to use measure first. Only use calculated column when you have a specific reason to do so. Now let us look at hierarchies, which is enabling drill down analysis. What is a hierarchy? It is a structured arrangement of data fields that allow user to drill down into detailed level of information within a single visual. Examples of hierarchies are date hierarchy, which can be arranged in year, quarter, month, down to the day. Example, start with the year 2025, then drill down to quarter, then the month, which is January, then the date, it could be 15 January. Now, in terms of product hierarchy, you can categorize the product, subcategory, and the product name. Start with electronics, drill down to laptop, then specific laptop name, either Dell or HP. Now, in terms of geographical hierarchy, you now start with the country, down to the state, down to the city, to the postal code. How does hierarchy improve report? It enables drill down analysis without creating multiple tables. It improves report interactivity and user experience. It helps to organize this data logically for business user. It finally allows users to explore data at their preferred level of details. Creating hierarchy in your Power BI. In the field of pane, right-click on the field, then select Create Hierarchy, then name the hierarchy, drag additional field into the hierarchy in the desired order, and then use the hierarchy in any visual to enable drill down. Benefit of using hierarchy: hierarchy enables advanced drill down analysis. It improves report interactivity and user engagement. It helps to organize complex data structure logically and also reduce cluster by replacing multiple visual with one number. Now let us look at data modeling best practice. That is the designing principle. Use star schema design, keep data model simple, use proper relationship, avoid bidirectional filtering, use measure instead of calculated columns, and maintain consistent naming convention. So these are the best practice. Now let us look at data modeling best practice continuously. Remove unnecessary data, optimize data type, minimize many-to-many relationship, document data model. Benefit of following this best practice include: it helps to improve report performance, easier to maintenance and scalability. It is more accurate analysis and calculation. It is faster data refreshing time. It facilitates better user experience, and finally reduce confusion for report consumers. The key insight here is that a well-designed data model is invisible to end user. They simply experience fast, accurate, and intuitive report. In conclusion, your data modeling foundation, you have now learned how to structure data, establish relationship that enables accurate and efficient analysis, which is a critical skill for every Power BI professional. What we have learned in this module include data model, relationship, creating and managing relationship, star schema, snowflake schema, calculated column, measure, hierarchies, and best practice. The key takeaway here is that a well-structured data model is the backbone of every effective business intelligence solution. It determines how data is organized, connected, and used for analysis, directly impacting report performance, accuracy, and user experience. Next step, with your data model now structured and relationship established, you are ready to move to advanced analysis using DAX, that is data analysis expression, thereby creating powerful calculations that unlock deeper business insight. Remember, structure your data well and your insight will flow. Thank you and have a nice day.